Okay, welcome back. Um, have you finished your exercise for question number 1?
Baru buat nombor 2.
Huh?
Baru buat nombor 2. Question 1 tu Roman.
Question 1, 2. Okay. And please remember that if this is a test, you should, this is a question from the test, you should spend around 20 to 30 minutes to solve the question. Otherwise, you will not have enough time to finish all questions in your assessment. Um, who would like to volunteer? Who would like to volunteer to share his answer? You can always give your answer in WhatsApp. Share your answer in WhatsApp. I will share here in my screen. First, I ask about volunteer. No one would like to be a volunteer. Oh, Mohimin. Want to share your answer?
Okay, I try.
Okay.
I send it WhatsApp.
Yes, send to WhatsApp. I'll share it here. Okay. I download it first. This is the one, yeah? Okay. Let me compare with my answer. For the first part is, okay. Can you see my screen that I shared here? And the answer from Mohimin. Can you see it?
Okay, cool.
Okay. Can you see the first the first question? Roman number 1. Okay. Here the question asks about I3, current I3 and power dissipated by resistor R3. Based on the answer on from Mohimin, I think he done it correctly. not correctly lah, 50% correct. The procedure is fine. However, the value of current, if you look at the value over here, it should be milliamp. Okay, 2.5 milliampere. Of course, first, if you look at the question, to find the current, what you need to do is you need to know that the voltage across R3 is the same value as the voltage supplied because of parallel connect. Yes, correct. And once you done with the current, you can calculate the power dissipated at R3 by using, here Mohaimin use the current back. 2.5 squared times 4 means that he used I squared times R. You can also use V squared over R, where the voltage is 10 volts squared and divided by your resistor, which is 4 kilo ohm. And here, the answer should be 25 milliwatt because of our resistor is 4 kilo ohm. And for the second question, Mohaimin got 1.66. I think it should be positive 1.66. And the answer should be 1.66 milliampere, not negative. Should include positive, and so should include milli over there. The answer for the first one also should be 0.83 milliampere. If you look at the direction of the current, the value should be a positive value. And for number 3, the answer from Mohaimin, he got 2 ohm and 4 ohms. I think the value is okay, but not okay, 50% okay, because your resistor is in kilo ohm. Your R1 should be 2 kilo ohm and R2 should be 4 kilo ohm. And for total resistance is for question number 4. To get total power, what Mohaimin did was using the total resistance, total current, and later on calculate the total power. Yes, you can do that, and of course, it's a correct way. However, I think the value over here, we have problem here. The value should be 50 milliwatt, 50 milliwatt, not 100 watt. Okay, in general, what I can comment over here, the way or the strategy that Mohaimin tried to get the answer is, I think, correct. However, there was slight mistake in terms of milli, kilo, and maybe the calculation of power here has something, has some problem. Okay, I will share my answer. Okay, thank you so much, Mohaimin. Very good attempt. I can say from, let's say, if this question is 10 marks, 60% or 70%, I think I can give the marks lah. Okay, can you see the overall answer? Yeah. This is from test, I think 2017, I believe. I'm not sure. Test of final. Okay. Yes.
Doctor, the number 4, the RT would be 1 kilo ohm, right?
My answer is correct. Wrong lah here. Yes, your answer is correct. So I did something. I did some mistake over here. Here should be 1 kilo, and the total power should be 100 milliwatt. Thank you so much. Mohammed, is that Mohammed?
Hadith.
Sorry, who is that?
Hadith.
Adif. Okay, thank you, Adif.
Hadith.
Yeah,
Hadith.
I did a mistake over here. It should be 1 kilo ohm, and this should be 100 milliwatt. Never mind. I just want to describe the approach that you should think about. As I mentioned just now, what Mohammed had done was, I think, overall is correct. However, there's some problem with milli, kilo, and so on. Okay, let me see the first answer. Here, my answer, for calculating currents, I use a basic Ohm's law, where here I use V divided by R3, and it give me 2.5 milliampere. That's why I think when you try to calculate the answer, make sure you pay attention at the value of resistor. It's sometimes without kilo, it's sometimes with kilo, and sometimes maybe it might be a mega ohm. Okay, pay attention with the units of the value units. Okay, for power, Mohammed use I to calculate P power at resistor 3 ohm. So sorry, power at R3, and here I use voltage, because I know that voltage across all these 3 resistors should be the same, and therefore the voltage drop across R3 also 10 volts. I use V squared over R3 to get my power dissipated at R3. And for the total current, sorry, not total current. Second question we would like to calculate what is the value of R1 and R2. Okay. Now the strategy that I use is that if let's say I put it over here, if I know what is the current flowing here and here, means that I can use it to calculate what is the value of R1 and R2, because I know what is the value of voltage over here. So R can be found by using V divided by I. So that's why in the first step over here, for second part, I try to find what is the value of my currents. So here, given that I1 equals to 2I2, I put in into current Kirchhoff law, where from current Kirchhoff law, I total equals to I1 plus I2 plus I3, and I substitute here. Maybe I substitute I1 equals to 2I2, and later on maybe you can also substitute I2 equals to I1 divided by 2 as well, to get the value of your current. And at the end, I will get my I2 and also I1. And to finish up my calculation, where for the value of R1 and R2, I will use a simple Ohm's law over here, V divided by the current, and I will get my resistance value. So here R1 is around 6 kilo ohm and R2 is about 12 kilo ohm. Okay, that's for question part number 2, I believe. Mohammed you didn't calculate that one, yeah. Just finding I1 and I2. That's why I think if this is 4 marks, maybe around 3 or 2 to 3 marks could be obtained from this current that you calculated. All right. Am I correct? Am I missing anything? No.
Betul, can I ask something?
Yes, correct. Go on.
The formula,
Uh-huh.
we can just arrange the formula before we put the number. Can we just like Dr. did, it's we arrange the formula and then the last thing we will put the numbers. We
Yes,
can do it.
Yes, of course.
Oh,
That is, I think, easier for me. For me lah. I don't know what is your preference, but this
yes.
is, I think for me, I just arrange the formula first, and at the end, I put in all the values from my calculations from the formula, and at the end, I will get my result. Okay, you can do like this. This is I mean proper way to explain the examiner what's going on in your solution. If you just put in numbers, maybe if your number is correct, then that is fine. However, if your numbers is wrong, so it's for the examiner, it's quite hard to find what's wrong with your value over here. So we try to find the way to give you marks. So I really suggest that you start drafting your answer with the not with the value lah, with the formula first or with the equation first, and later on put in the value. Okay, for number 3, and for number 3, I think it's a bit different with number 2, because in number 2 we noted that R1 and R2 is given by 6 kilo and 12 kilo, but in number 3, R1 and R2 is given by 2 kilo and 4 kilo. Please remember that if you have resistors drawn like this, the symbol is like this, where you have an arrow across the resistor, means that this is a variable resistor. It can be any value. So for question number 3, the value of R1 and R2 is given by this condition, where in part 3, the condition is that R total or total resistance of these 3 parallel connected resistance is 0.5 R1. Then you need to work out your answer based on the requirement or the condition available in that part. So here it says that you need to find R1 and R2, and if R2 is equals to 2 R1 and R total equals to 0.5 R1. So based on this requirement or based on this information, you need to work out your answer. So here, if you have a 3 parallel connected resistors, this is the way you calculate your resistor, where R1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. And I substitute R2 as 2 R1. And also here, if you look at this R total, I substitute it with 0.5 R1. And if you do the mathematics, solve this equation, At the end, you will get your answer as this 2 kilo ohm and R2 as 4 kilo ohm. And for question number 4, it is stated that using the answer in part 3 means that R1 and R2 must be used based on the third part. So, you need to determine the power dissipated in the circuit. So use the resistance that you calculated in part 3 to calculate total power in part 4. I think part 4 is a bit straightforward. However, for part 3, it's a bit tricky. However, I think Mohammed managed to get the idea on how to solve question number part 3. Okay, is there any questions so far? I'm really apologize with my answer over here. This should be 100 milliwatt because the total resistance should be 1 kilo ohm over here. Is there any question from the floor?
No.
Nope.
Okay.
Okay.
Yes.
As you know that my calculation is wrong at unit. I just wrong at unit.
Yes.
So your mark will be given or not?
Yes. Mark will be given, still will be given. However, it's not a full mark lah. Maybe I think based on this work, I think around more than 50% could be obtained from here, because it's just due to the unit. Yeah, you miss out the kilo ohm and also milliwatt, milliampere, and so on. Okay.
Okay, thank you.
But I think it's quite sad lah. Macam you should get full marks on this. Just because of the unit. So you need to be careful next time. Please pay attention at the unit of the resistors, especially the resistor lah. And it will, because it will affect your current, the power. Okay. Right. That is for question number 1. For question number 2, it's a bit complex. Not that complex lah, because we just have two power voltage and also current source over here. In total, 2 sources lah. All right. However, the way we calculate this kind of circuit could be using a few options. Okay. Now, if you look at the question, it says here, find I/O using suitable circuit analysis / theorem. Okay, I need one answer from you guys. If you try to calculate this one, what sort of suitable circuit analysis or theorem that you have in mind to solve this one? Could anybody respond?
Superposition.
Superposition, yes, correct. Is there any approach? Any more approach that we can use? Thevenin. Thevenin, yes, also can, yeah. But I think before we get into Thevenin, maybe we should think about analysis first, because this is not something that you should really consider Thevenin or Norton theorem. This is something which is like, maybe you should think about node analysis, maybe you should think about superposition, source transformation, and mesh analysis. Okay, so if the question here didn't ask about Thevenin, I think you don't need to set up your Thevenin equivalent circuit. But It also one of the option. I'm not saying that you cannot use that Thevenin theorem. Okay, thank you so much for the answer. Yes, in my first, based on my first expression or my first opinion, I think the easiest one is maybe by using superposition, because in superposition, we only consider one source at a time. The other source, for example, voltage source or current source, should be considered as a zero unit, or the value is equal to zero. Either we try to short circuit the voltage source or open circuit the current source. Only consider one source at a time. But you need to repeat the process over and over. For example, if you have two sources over here, means that you need to repeat the procedure 2 times. First, you calculate IO, maybe IO prime. Second one, you should calculate IO double prime, and later on, sum that value together to get your final answer. Okay, I will share my answer over here. Where's my answer? Is this one? Yep. Okay, if you see any mistake in my answer, please notify me. Yeah. Okay. As I mentioned earlier, the first thing that I think about is a superposition, because I think if I have only one source at a time, it's easier for me to analyze the circuit. If you look at my approach over here, I also use superposition. However, when I try to use superposition, when I try to set up back my, simplifies back my circuit, I saw, I also need mesh analysis in order for me to calculate the value of IO over here. So here I would use both superposition and mesh analysis if 2 ampere current source is active, because once I set up my simplified circuit, or I try to redraw my circuit, I saw over here I have like 3 meshes, and also maybe if you have maybe if you like to use Y delta transformation also can over here, but here I use superposition and also mesh to calculate what is the value of IO. And remember, if you are using superposition, means that you need to do the procedure over and over based on the numbers of your sources. Here, first, when 2 ampere is active, I would consider my voltage source over here is short circuit. And I try to calculate IO flowing through 8 ohm resistor, and I label it as IO prime. And once I simplify the circuit, I saw 3 meshes, and I decided to use mesh analysis. Here, for mesh number 1, current around mesh number 1 is given by 2 ampere. It is because we have a current source connected within loop number 1. So now loop number 1 is settled. I do not have to I don't have to calculate the voltage drop across each of the elements, the resistors. And I move on to mesh number 2. For mesh number 2, look at mesh number 2 over here. First, what I did was I tried to I put in the polarity of voltage drop across these 3 elements: 3 ohm resistor, 4 ohm resistor, and 8 ohm resistor. And the 4 ohm resistor, if the current is flowing that way, okay, this is the polarity should be at the top. Positive polarity should be at the top, negative should be at the bottom, and For 8 ohm resistor, the positive is at the right, negative at the left. For the 3 ohm resistor, positive at the bottom, negative at the top. And I try to work out the voltage, Kirchhoff voltage law around loop number 2. And to get voltage across this 4 ohm resistor, where I label it as V1, okay, V1 is given by I2 times 4, okay, plus I have voltage over here. I label it as maybe here VO, if I'm not mistaken. But if you don't label the voltage drop, also can. However, you need to know what is the equation for voltage across this resistor. And voltage across this resistor is given by IA times 8, where you know that you should know that I that flowing through this resistor should be the combination of these two, or loop number 1 and loop number 2 and loop number 3. So that's why I put it as IA, because I need to first determine what is IA first, where IA is given by I2 minus I3. This drawing is based on the point on the right hand side. Okay, and the third voltage drop is at 3 ohm resistor, so I label it as IB times 3 is the voltage drop over here. And the voltage drop over here is given the current flowing through this 3 ohm resistor is basically the current combination between I2 and also I1. So I would consider junction at the top over here at the middle top. So if you look at the junction here, you see that the current coming into the node is 2 ampere and also IB, because I label IB to be in the same direction as I2. And I2 is at the right hand side. Then by using Kirchhoff current law, I would determine IB equals to I2 minus 2. So in the next line of the my solution is just putting the equation back. So for IA is I2 minus I3, IB is I2 minus 2. And later on, when you try to solve it, you will end up with this first equation, where I have two unknown variables, which is I2 and also I3. Here, my equation is 15 I2 minus 8 I3 equals to 6. And for mesh number 3, after I finish mesh number 3, mesh number 2, I proceed with mesh number 3 to get my second equation, which is based on the Kirchhoff voltage law or voltage drop around loop or mesh number 3. There are 3 resistance inside the loop. We have 8 ohm resistor over here, we have 6 ohm, and also the 8 ohm at the middle. So based on the loop, I set up my Kirchhoff voltage law equation. So before I set up my Kirchhoff voltage law equation, I put the polarity of voltage drop first. First, I put if the current is flowing in that direction, means that positive should be at the top, negative should be at the bottom for the voltage across 8 ohm resistor. And for the 6 ohm resistor, the positive should be at the bottom, negative should be at the top for the 6 ohm resistor voltage drop. And for the 8 ohm that we have in the middle should be positive at the left hand side, negative at the right hand side. So that's complete my voltage drop, and I can write down my voltage, Kirchhoff voltage law equation. And here I have I3 times 8 is the voltage drop across 8 ohm resistor at the far right. And I have IC times 6. Why I put IC? Because I know that this is not I3, it is a combination of 2 currents. the currents, the IC is given by the combination of I3 and also I1. So here, I will consider the node middle bottom over here as I draw like this, where I have I3 coming in and IC as well as 2 ampere going out from that node. So from there, I can get my IC is equals to I3 minus 2. And for the final one is basically current in that direction that would produce the voltage drop across this 8 ohm resistor. And earlier, I've already know that if the current is flowing in that direction, can I comment? Okay, maybe I put it like this. If the current is flowing in that direction, here, oh, sorry, I should put it here in that direction. It is given by IA. Since I need a current which is flowing in the opposite direction, that's why I put it as negative IA. So I don't need to redraw. Actually, I don't need to redraw, but here I still draw it for you because try to explain you what's going on in my solution. So here I have negative IA times 8, or you can also put it as whatever you like lah, ID, IE, but you need to know that ID or IE that you note for the current is given by I3 minus 2. So the next line, as I mentioned earlier, is just putting back all the information that I gather from the question, from my circuit. And the rest should be the mathematics, where at the end, if you try to simplify the equation, you will end up with two unknown variable, also two unknown variable, which is I2 and so I3. And this is my equation number 2. And later on, you can solve these two equations using your own preference. Maybe you can use your calculator or matrix. I mean, maybe you can use matrix, maybe you can use what do you call it, simultaneous equation, either substitution or elimination to solve it. Here I show you how I use matrix inverse to calculate or to solve these two equations, equation 1 and equation number 2. First, I set up my equation in matrix form. Remember, in matrix form, this is 15I times I2, negative 8 times 3, so it will represent this part. Okay, equals to 6. Okay, the right hand side will represent this part. Okay, and for this, the elements at the bottom over here, negative 8 times I2 plus 22 plus I3 times I3, it's for the second equation. And the second value over here is the value that you see for the second equation at the right hand side. So the value that you see over here is basically the inverse of this value. Let's say this value is A. Okay, value over here is matrix A inverse. Okay, inverse. And when you try to multiply it with a 2 by 1 matrix over here, you will finally get the answer. If you remember that for matrix, if you multiply both sides with A inverse, this side, okay, this element will be eliminated. Oh my goodness, what happened? This matrix A will be eliminated, where what happened over here, if you multiply with both sides with inverse matrix, inverse A, for example, here I have the left hand side as I Okay, this is I2, I3. Okay, this is the left hand side equals to A inverse times, I should write it down here, 6, and this is 12. Okay, this part, okay, these two elements is will result as the identity matrix. So that's why what we left is like I2, I3 is equal to this calculation. And at the end, you end up with a 2x1 matrix where at the top here is your I2, at the bottom here is your I3. And to get IO, remember that IO is also given, okay, IO is current flowing in that direction. Current flowing in that direction is IO. IO is also given by negative IA or I3 minus I2. So based on my calculation, I3 minus I2 is 0 ampere. Okay, this is for IO prime. And for IO double prime, when 3 volts is active, the current source here is, you should treat, or we should treat the current source as open circuit, and this 3 volt voltage source is the only voltage, only source that available in our circuit. You should consider only one at a time. So now, based on this circuit, I try to simplify it back. If you look at the simplification, this part is considered negligible because we have open circuit over here. So this resistor can be neglected. That is because this one is open circuit. Remember that if you have open circuit, it means that the current over here, I don't like this one. Okay, the current over here is equals to 0. Oh my goodness. Maybe current here lah. Because we have open circuit, and if you simplify, you don't see any 10 ohm resistor in my second circuit, or the circuit that I have been I simplified from the original circuit. And the way I simplify my circuit is that I try to put my voltage first, and from the voltage here I have two parallel branches. First one consists of 6 ohm, so that's why I have 6 ohm over here, and the second one I have 8 ohm over here. So first I draw this one is number 2, and this one is number 3. And later on, from 6 ohm resistor, after I pass the 6 ohm resistor, I also have 2 branches. However, the second branch is considered negligible because of this open circuit. Then I only consider this the branch at the left of my left hand side, which consists of 8 ohm resistor. That's why you see here, after I done with 6 ohm resistor, I connect my wire into this 8 ohm resistor. And towards the end, or at the end of this 8 ohm over here is basically here, right? It should be connected back with this 8 ohm resistor that I have in the second, in my second branch earlier. So this part is basically at this area, and these two should be connected together. Then that's why this one is connected. And later on, I go into my circuit, I will get into this 4 ohm resistor. So now I will draw this 4 ohm resistor, and this 4 ohm resistor, if you, after that 4 ohm resistor, you also look here, we have 2 branches. first branch is considered negligible because of open circuit, and the second branch is this 3 ohm resistor. And after 3 ohm resistor, get back into a negative terminal of our voltage source. So this is sort of circuit simplification that you should have in mind. And looking at the circuit itself, I think I don't have much problem to calculate I/O, because in my strategy, I think if I have this I total and I can divide these branches, the current at these two branches to get my I/O. I don't need to use node, or I don't need to use mesh or anything, because I just use a simple voltage divider, current divider rule to calculate. But first I need to calculate my I total. To calculate I total, I need to find R total. R total looking from the source. So looking from here. R total from here. So from here, I see that these two is connected in series, and later on connected in parallel with this 8 ohm resistor. And once I combine this, I will get one resistor, and later on in series with the other two resistor at the bottom. So this is what would happen if you solve this parallel connected resistor. So now here I have RA. I label this branch, these two branches as RA. R 6 ohm plus 8, because these two is connected in series in parallel with 8 ohm resistor. And to get my R total means that RA plus 3 plus 4, and finally I will get my R total. And later on, to get my I total, I just use voltage from the source divided by the total resistance. Here, the voltage is 3 volts divided by 12. It's 0.2479 ampere. I also missed the unit over here. It should be 0.2479 ampere. And finally, I know that my I/O is at this side. And to get I/O, I can use current divider. So the current divider that I show you over here is, I try to divide two resistor. For example, here I will draw it back. Here I have 8. Here I have 6 plus 8 is what, 14, right? 14. And I try to find what is current over here, I/O. And originally I have this I total. Okay. And I use this kind of equation where to get current here at the right hand side, what you need to do, you need to consider the resistor at the opposite branch divided by the sum of these two branches and times with the current coming into these two branches. So this is what happened when we try to calculate using current divider rule. You don't need to consider this 4 and 3 ohm resistor, because you know that this is the I total divided by these two branches, and later on it will get together, and the current flowing these two resistors, 4 kilo ohm and 3 kilo ohm, is also, the value is also I total as well. It is 0.2479. So here it split and we get back together at the bottom. Okay, to calculate what is the original or what the exact value of I/O is by using superposition. You need to sum the value of I/O that you calculated over previously. First, I/O prime and I/O double prime. You need to sum that two together. Then here I finally got my I/O as 0.1578, or you can also simplify it as 0.16 ampere. So that's the solution for using superposition. You have any questions so far? Can you follow the solution?
Yes.
Yes.
Maybe.
maybe you need to do some revision back, because your test is just around the corner. Maybe next week on Saturday. This is the thing that you need to really the knowledge that you have here is really important. You need to really know the knowledge. Okay.
Doctor, if you
Yes.
have a question like this, can you send to us?
Huh?
If you have the question like this,
Uh-huh.
another question like this, can you send to us?
Yes. If you look at the activity activity week 5, you have equation. You have circuits over there, right? You can always practice using that circuit. Try to use the method that you learned in previous weeks. For example, maybe you can use mesh, maybe you can use node. If you look at class activity question, class activity week 5. Okay.
Sir,
Yes.
I wanted to ask, how did you assume there is an open circuit in the mesh analysis?
Okay. This is not assuming. I'm not assuming this one is open circuit. It's like the procedure of doing superposition, where in superposition you need to what call it, you need to consider only one source at a time. So other sources should be treated as 0 voltage or 0 current, 0 ampere. For example, for these 2 ampere, remember that earlier we have voltage source over here. I treat this voltage source as short circuit, because if I treat this one as short circuit, it will leads towards V equals to 0. So that's the procedure of using superposition theorem. You need to consider only one source at a time. And for the second one, if you look here, I consider this 3 volt active. Means that the current source that I have earlier should be treated as 0 ampere. To treat current source as 0 ampere, you need to make it as open circuit. Am I clear?
Yes, sir.
Okay. All right. This is the steps, or the beauty of superposition theorem, where during your calculation you only consider one source at a time, and then you zero all other sources. For current source, you make it as open circuit. For voltage source, you make it as short circuit. And that is not that. I think that one is not that hard. The most difficult one, I think, the harder part is that if you've already done that one, and you try to simplify it, then this part, I think, this is very crucial. The way you process what you have done in the for the superposition. You know that for voltage, you put it short circuit, for current open circuit, and then later on, how do you calculate this part? That one is also crucial. And same goes to here. And the way we solve the circuit that we simplify is we do have a few options. For example, at the top over there, I think mesh is the most suitable one. And for the second, for IO double prime, I think a simple current divider rule is the most suitable one, the easiest way for me to calculate it. Okay? Are you with me? Any question? Okay. All right.
No.
Okay. Then we can proceed. All right. As I mentioned earlier, from the question, it says that using suitable circuit analysis or theorem means that you can use any circuit analysis or any circuit theorem that you think which is easier for you, the easiest way for you. So here, what I have in mind, first I try to use superposition, but I think it's not that easy. And because I need to calculate I/O 2 times, because I have two sources over there. And if I have 3 sources, means that I need to calculate 3 times and later on combine all my 3 answers of I/O. Maybe in my next solution is by using mesh, maybe it could be easier. For example, here, if I directly apply mesh analysis to get I/O, I can straightforward get my answer as 0.16 ampere as well. So it depends on your preference. Okay, I try to explain for mesh analysis. And remember that whether it is a mesh or whether it's a node analysis or superposition, it should give you the same answer at the end. So I/O, if you see my solution over here, I/O at the end, I also got it as 0.16 ampere. Okay, if we consider mesh analysis, okay, mesh means that you need to label your meshes, as well as you need to note or label your polarity of voltage drop across within the loop. Okay, if this is the circuit, maybe I consider this one is I1, loop number 1, loop number 2, loop number 3. And okay, first we settle mesh I1 first. To solve mesh I1, what I need to do is I need to set up a voltage, Kirchhoff voltage law around the loop. To set up a Kirchhoff voltage law around the loop, first I need to identify the polarity of voltage drop across each resistors. Okay, if you consider this is the mesh, the first mesh. Okay, I have voltage drop across here, I have voltage drop across here, and across here. Based on the direction of a current that I assigned earlier, so if the current is flowing in that direction, this should be positive, this should be negative, and go around the loop. I have this positive and this negative, and furthermore around the loop I have this should be a positive, this should be a negative. So that's how I assign my voltage polarity of voltage drop across each resistor. This is to make my calculations more transparent and easier to check my mistake. So let me erase first. Why? Okay. Now, for mesh number 1, if I try to start from this point, okay, this point, I have voltage drop across this 8 ohm resistor, and the current flowing through this 8 ohm resistor is considered as I1. Okay, this is considered as I1. The voltage drop is I1 times 8. And furthermore, for this resistor, to calculate voltage drop over here, it's given by, okay, this IA, I just assign my notation over here. You can assign any notation. You can denote it as IX or maybe whatever you like lah. I note here as IA, where if I know what is IA and times the value of resistor over here, I will get the voltage drop. So voltage drop across here is given by IA times 6. And voltage drop across here is given by another current, not I1, because you see here we have a junction, means that this is definitely not I1. So this is another notation. I put it as IB. IB times 8 will give me the voltage drop across this 8 ohm resistor. So from here, I only need to determine what is IA. So to determine IA, I would consider this junction first. Okay, here. At this junction, I have I1 going in, I2, I2 or 2 ampere is going out, and IA is also going out from that node. So here I have IA equals to I1 minus I2. And I put IA as I1 minus I2 in the second line. For IB is I1 minus I3. This is due to the junction over here. Okay, junction over here. Junction over here tells me that IB is going into that point. I3 also into that point. I1 flowing out from that point. So why I didn't consider this point? Because it's basically it is the same. However, it's quite hard because I don't have a clear current coming in and coming out from that point. It's easier for me to use this at this point. So you can either use this point or this point, but I choose this point because it is easier for me to determine the current coming in and also the current going out from that point, because this is definitely I3 and this is definitely I1. I only need what is the current in pointing towards that point, which is IB. So IB here I have I3 minus I1. And solving that part, I will end up with 3 unknown variable, I1, I2, and I3. So this third and fourth line is basically only involve mathematics. The crucial part is these two lines, and also this definition. If you can give me your answer like this, I think there's no problem, because you can always check back what is if something wrong in your answer, you can check it back. Okay, now for mesh number 2 is given by I2, because this is we have a current source within loop number 2. So definitely I2 is given by 2 ampere. So now we don't have to recalculate or set up the equation using Kirchhoff voltage law. However, for I3 here, for mesh number 3, you need to set up your Kirchhoff voltage law equation. And we apply the same method. First, the direction. And from the direction, we apply, we try to identify the polarity of voltage drop. For example, if the current is flowing in that direction, if the loop is considered flowing in that direction, we have voltage drop here should be positive at the top, negative at the bottom, and go around the loop. We have 8 ohm resistor, positive at the bottom, negative at the top. Go around again for 3 ampere, the positive should be at the left, negative should be at the right. And from the definition of the voltage drop over here, you can set up your third equation. I would not, maybe I will skip this part because it seems like the same. Maybe you can have a look at the solution that I will post in e-learning later on. At the end, you will end up with this equation, 3 unknown variable. And again, if you try to solve the 3 equation, maybe you should substitute the second equation into first. Maybe this is not first and second. This should be first and third equation. Okay, this is wrong basically. This is third equation. And if you look here, I substitute equation number 2, I equals to 2 equals into this equation and also into this equation. And I will end up with this sort of equation number 4 and equation number 5. And the easiest way for me to solve it is by using inverse matrix, because I know that I'm using MATLAB, so it's easier to do my calculation in MATLAB. And if I have solving two simultaneous equation, it's easier for me in MATLAB. It is easier for you to use matrix multiplications. So if you look at here, if you consider here is your matrix A, and what you have over here is basically the inverse of A. Inverse of A inverse. And A inverse multiply with this 2 by 1 matrix will give you the answer for I1 and I3. And going back to my circuit definition, where here I have the IO. IO basically in the same direction of IB. And first, I know that IB is given by I1 minus I3. So I just put in as IO equals to IB equals to I1 minus I3, and this will give me the same answer that I have using superposition theorem. Okay, maybe to calculate this one, okay, you can use a few approach. As I mentioned earlier, maybe you can use inverse matrix, maybe you can use substitution, elimination. But if you have MATLAB software, then it is easier for you to use inverse matrix to do that. And I checked in internet. In internet, we have like this website where you can always calculate the inverse matrix easily from here. So here the website is symbollab.com, where if you try to calculate the inverse matrix, for example, inverse, I put it matrix over here. Okay. No. Oh, right. Inverse matrix 2 by 2. Okay. Right. I put my number 22, -8, -8, and 15. Okay. And then go. Wait for me. Okay, you will get the answer instantly. This is the answer for inverse of this matrix. And the step is as mentioned over here. In this course, basically, I'm not asking, I'm not assessing on your mathematics, because you have a lot of option or you have already learned mathematics in different course, and you also have option using maybe websites, maybe calculator software, maybe to calculate the difficult part. So in this course, I only ask about the circuit. So for the circuit, you need to know how to process your circuit, how to analyze your circuit. And for the mathematics, you can always use this sort of, maybe you can use websites and so on. Okay, and remember that if you try to present your answer, please don't leave your answer in fraction form. I need your answer in decimal form so that it's easier for me to give you marks. Okay, if you look at both solution, both give me the same answer, either superposition or using mesh analysis. I also will show you another one, but unfortunately, we don't have much time to do that. I also had calculated my answer for IO using node analysis. This is node analysis that my solution of node analysis to find IO. Okay, if you, I think you should spend some time lah looking at the solution and try to think about how do I get that and how it should be calculated and so on. So I think the most important thing for me to deliver today is I think being delivered. First, the introduction of website or tools for you to calculate simultaneous, and also the way you solve superposition as well as mesh. I don't have much time to explain you about node analysis, but I will leave you with the solution, and maybe you should revise the solution and think about why I did like this, why I did like that. Just don't just follow and try to call it to go line by line of my solution. All right. Any questions so far?
So far, so good, sir.
So far, so good.
Inshallah.
Inshallah.
Inshallah. Sir, Mark is asking you a question in the chat.
Yes. It's asking about video for today on our e-learning. To upload our lecture class or video for today on our e-learning. Okay.
Can you upload the today's class on the e-learning?
Because you see here, if I the record the recording size is quite substantial. It's quite big. So that's why I didn't put it in e-learning. That's why. Maybe I'll try another way. Maybe put it in YouTube. Maybe, right? But
Yes, because so that we can revise the mesh analysis, superposition analysis, all of that, because it's a bit hard to cope all of it together.
I know. That's why I provide with the the video from YouTube. You should have a look at the video as well. And maybe I'll try I try to upload the video first. I think for tutorial is okay, but for class, the file is very big here. It's around 300 or 400 meg.
Okay, sir.
To upload that one.
What about the answers? What about the answers?
Answers, yes. I always put the answers in e-learning.
Okay, thank you, sir.
The file over here that you saw here is already maybe not already lah, but I always put it in e-learning where you can always get go through the answers. But our conversation here is, I think, it's very difficult for me to upload it in e-learning.
It's fine, sir. It's fine.
But I will try. Maybe I try another way, put it in YouTube. Maybe it's a bit lighter if it's available in YouTube, right? Okay. Do you have any questions so far?
No.
Have you filled out the attendance?
Yes. Yeah, I filled out.
Okay.
Yes.
For those who missed the link, here's the link. And what else? Yeah. Okay. Before we leave, as usual, we try to take your handsome picture over here. I try to get to know you guys from your picture. I mean, from your webcam lah. Why Amir left? I tried to snapshot your attendance. Okay, well, here. The same guy. The same guy. What happened to the rest? Wang, Izaidi, Mok, Nakanishi, Toru. Where are you guys? Adam here? Okay, Adam here. Okay. Toru. Omer well is here also. Okay, good. Nathan is here. Muhaimin is here, also here. Thank you, Muhaimin, for sharing your answer. Okay, I'll snapshot now. All right. Anyway, thank you so much for your attention. And